It's a pleasure to welcome back to the show Bob Werb, co-founder of the Space Frontier Foundation. Bob, we've been hearing so much in the last couple of years between the Mars rover and the discovery of certain exoplanets, like most recently Kepler 452b, about space travel and space exploration. But a conversation that's not had as frequently is what is our capacity to really explore any significant part of our solar system, never mind the universe. So let's start there. Over the last 5 years, have there been any appreciable advancements in our ability to travel throughout space?
Yes, there's been dramatic progress, not so much on the technical side as on the programmatic side, as we've shifted from a purely government centrally controlled system to one that makes more use of the power of free enterprise, which of course is America's strength.
So, what specifically has changed in terms of, is there any good analogy that you could give with regard to the vastness of space and our ability to explore even a fraction of that?
Well, with the kinds of technology that are in development today, we pretty clearly have the ability to travel with people and machines throughout the solar system. Um, and to make use of the resource of the solar system to make life better here on Earth. And that's going to be the focus of almost all space activity over the next, decades. Going beyond the solar system is another whole thing, and we can talk about that if you'd like.
Yeah, let's talk about that because, when people hear, oh, Kepler 452b, for example, is one of the closest of these types of Earth-like planets that have been found, and it's 1,400 light years away. Talk about how far we are from being even a tiny fraction of the way to being able to traverse that distance.
Really, really far. 1,400 light years is a fantastic difference. And it's way beyond our ability to do over the foreseeable future. For now, we really are limited to the speed of light. And I have no opinion at all about the possibility of warp drives or traveling through wormholes. Humanity simply doesn't know enough about the physics involved to even say if it's in the realm of the possible. But who knows? Maybe 50 years from now, somebody will find a way around the speed of light. On the other hand, maybe it won't happen for 50 centuries. Well, who knows? Maybe 50 minutes from now, somebody will figure it out. But for now, for today, I think for the next 50 minutes, it's perfectly safe to leave faster than light travel in the realm of fiction. If in fact we're limited to the speed of light, trips to other star systems will take a very, very long time. Even worse, for those in a hurry to get started, is that it makes no sense to start out on a really long trip if you think that somebody leaving decades after you with better technology would get there first.
All right, well, let's explore that because I know that that sort of thought experiment quite well. So this is the idea that at any point where you might start out on a journey, if you believe that 5, 10, 15 years from now, there's going to be a new method of travel that is so much faster than the one we have now, that the future travelers or the future craft will arrive wherever it is that we're trying to get before what we would be able to launch now, that it, logically speaking, doesn't make sense to launch anything now. But isn't that sort of a dangerous path to go down because you may end up never launching anything because you think, hey, in the future somebody will pass us anyway?
Well, there is that possibility. I think eventually you get to a point where either the pace of change in technology or space technology slows down a little bit and you have some kind of sense that it makes sense to start out on these kind of really long trips. Or alternatively, you get up to a significant fraction of the speed of light. And then, time dilation and all that stuff comes into play. And then again, it makes sense to start thinking about sending people to other star systems. But this is, really far in the future because now we can't get anywhere close to the speed of light.
Let's talk about something a little bit closer to us in terms of distance into the future, which is manned travel to Mars. I'm sure that you've been following the Mars One project and other ideas that are out there about getting to Mars, even starting to launch towards Mars in the next 6 to 8 years. What's your sense about how realistic some of the current plans are?
Well, obviously, some of the plans are exaggerated for marketing purposes, but I think, and to address Mars One, I have no idea where they'll raise the money they need, but they are on the right path in one sense, is that it's a one-way trip. I've never been able to figure out why people think we should use government money to send people to Mars and then bring them back. I can certainly think what the public purpose might be for sending people to Mars, but if so, what's the public purpose for bringing them home? If you're sending people there, they really ought to stay and colonize the planet and do what it is you sent them to do it for. I think it's inevitable that we'll have people on the surface of Mars, but it, it's the question is why are you sending them and who's paying for it?
And what do you think the right reasons to go to Mars? What do you think the right reasons are?
Well, long ago I was a biology major, and to me the most exciting thing is that we might be able to find microbial life on Mars. And while we can certainly collect samples robotically, it's very hard to build a good laboratory that's completely robotic or teleoperated. So, one could imagine wanting to build a good lab on the surface of Mars to bring the samples to, so you can really look at and see if there's any extant or perhaps extinct microbial life on Mars. I think it's one of the most exciting things that we could do, and I would love to see it happen.
Let's talk about that a little bit because I got an interesting question from a viewer wanting to hear from you kind of about microbial life. And the question was phrased or posed in this way. Humans and life in general on Earth have adapted to the microbes and bacteria that exist here over a very, very long time. If we were to find microbial life on Mars or elsewhere, wouldn't that pose a pretty significant challenge to humans living there because we would just basically be dropped in completely unadapted to that local microbial life?
We would be unadapted to them, but they would also be unadapted to us.
Okay.
It becomes kind of improbable, I mean, fantastically improbable, that they would cause any diseases in us.
Is it so that's not a likely scenario?
Not a likely scenario. Now, reverse contamination is a concern. You have to worry that there are microbes on Mars that would thrive here on Earth. Now, at least some material from Mars gets to Earth because asteroids from Mars land up on Earth. But of course, they've been in space a long time, and as far as we know, nothing has ever survived the transit from Mars to Earth. But if we start bringing back microbial life, I mean, who knows? It might thrive in the Arctic, where very little Earth life thrives. It might, we just don't know. So we do need to be very careful about what we bring back from Mars.
The other thing I want to touch on in terms of thinking about space travel is the topic of radiation. So we know that when you fly in a commercial airplane, you're exposed to more radiation than you are when you're standing, at sea level on Earth. But the difference in the radiation would not really be enough unless you're essentially, from the studies I've read, on a plane almost 24 hours a day to cause a significant impact on health. Not so when it comes to travel through space, where radiation is orders of magnitude higher than when you're on an airplane. So talk about that challenge with regard to long trips into space.
Yeah, first of all, I want to be clear that this does not affect orbits like the International Space Station,
Right.
where they do not get a whole lot more radiation than pilots get on very high airplanes. But once you get out beyond the magnetosphere, you have to deal with a very serious radiation problem. And there really are only two prospects for dealing with that. One is to use a lot of shielding, and that would be, anything from lead to water. the alternative is to find a way to get the human body to live with that kind of high levels of radiation. There are people working on that. I don't know how much progress they're making you know, but shielding is certainly possible.
So that is, it sounds like, an issue that has to be dealt with if we're going to be doing any of these longer trips.
Or if we want to live in space, the same would be true on the surface of Mars or on the surface of the moon. You know, you don't actually get to go live on the surface of Mars. You get to go live underneath the surface of Mars.
All right, let me remind everybody that we have been speaking with Bob Werb, co-founder of the Space Frontier Foundation. Bob, always great to hear from you. Thank you.